Hi everyone, this is TJ with Avidyne again. In the following quick video, we're going to be discussing the IFD interface with GPSS converters and talking a little bit about how that works and what to expect. As always, nothing in the following video is approved data. This is for reference use only. For approved data, please refer to the IFD installation manual. Make sure you're looking at the latest rev. So just as a block diagram kind of setup on how this works, with a GPSS converter, you have your aircraft heading system, which provides your heading error out. Without a GPSS converter, that heading error out would be connected directly to the autopilot, and you put the autopilot in heading mode, and off you go. When we add a GPSS converter, what we're essentially doing is we're adding in another block there where the aircraft heading error is going to come into the GPSS converter, as well as ARINC 429 coming from the IFD. Now that ARINC 429 you see down here, this can be any of the gamma varieties. So if you've already got other stuff in the airplane that's using, gamma 429 graphics with intersections, you can just tap into that. That's fine. What this GPSS converter is actually listening to is ARINC 429 label 121. So any of the gamma variety ARINC 429 outputs are going to provide that label 121. So you should be good to go. And what will happen is that GPSS converter is going to give you a push button. So when it's in heading mode, as you see here, where the heading is highlighted in green, what it does is it turns off this ARINC 429 out and just passes this heading error straight through to the autopilot. Just like the GPSS converter wasn't there and the autopilot was in regular heading mode. Nothing new there. Here's where it becomes a little bit different. So when you push the button to put it into GPSS mode, basically shuts off this heading error input, and it takes this ARINC 429 roll steering label and it converts it to an analog heading error out to the autopilot. So you still have your autopilot in heading mode, you just have engaged GPSS, which controls what this GPSS converter is putting out, whether it's passing through the heading information or the ARINC 429 GPS data from the IFD. And that's pretty much GPSS converters in a nutshell. They all kind of work that way. Couple of things to keep in mind. Since that ARINC 429 data stream out of the IFD has to be configured, it's important to understand the GPSS converter that's installed in the aircraft and whether or not it has the capability to automatically detect line speed. So with ARINC 429, you can either use low speed or high speed ARINC 429. There are some GPSS converters out there that will automatically detect what that line speed is on boot up. If that's the case, then the IFD should be configured for low speed only. All right, and here's why. When the IFD runs through its self-test routine on boot up and it does the test outputs and everything, it does a test output of low speed ARINC 429 data. So if it's configured for high speed, it's not actually going to switch it over to high speed until you hit the enter button on the IFD. So if you have a GPSS converter that automatically sets itself to whatever that line speed is coming in, it's going to go ahead and set itself for low speed during that test routine, and then as soon as you hit enter on the IFD, it's going to switch it to high speed, and now your GPSS converter is going to fail. It's going to fail that GPS because line speed changed on it after it set itself for low speed. So in those scenarios, you want to make sure that the IFD is set for low speed. And as always, if you have any questions on GPSS converters or anything else IFD related, feel free to shoot an email over to techsupport@avidyne.com. And thanks for watching.